Welcome to today's lesson on investigating temperature change. Today, we're going to step into the lab and dive into a practical that will bring our study of energy changes in chemical reactions to life. But first, over to Sam, our lab technician, to outline what safety equipment we need.
Hi everyone, I'm Sam. Before we get started, make sure to put on your lab coat, safety goggles and gloves. In our practicals, we must prioritise safety at all times.
Thanks, Sam. Now, while we're getting suited up, let's quickly refresh what we've covered so far. We've delved into the concepts of exothermic and endothermic reactions. We've learned that exothermic reactions release energy to their surroundings, often making things warmer, while endothermic reactions absorb energy, typically resulting in a temperature drop. We've also examined various types of chemical reactions such as acid-metal reactions, acid-carbonate reactions, neutralizations, and metal displacement reactions, understanding how they differ and the energy changes involved. All these concepts lead us naturally to today's practical, investigating how different variables affect temperature changes in these chemical reactions. By conducting real experiments, we'll be able to observe firsthand how varying conditions can influence the amount of heat energy released or absorbed. We're almost ready to dive into the details of our practical. But first, let's explore why this experiment is both exciting and valuable. First, understanding how different variables affect temperature changes in chemical reactions is not just an academic exercise. It's incredibly relevant to real-world applications. For instance, exothermic and endothermic reactions are fundamental in industries ranging from food production to making batteries, and even in medical therapies like cryogenics. By exploring these reactions, you're gaining insights into processes that are essential for various technological and industrial applications. Second, this experiment offers a concrete way to understand thermochemistry, a key area within the broader study of chemistry that focuses on energy changes during reactions. Observing how energy is absorbed or released in reactions helps solidify complex theoretical concepts. It connects the dots between what we've learned in textbooks and what we can observe in the lab. And finally, conducting these experiments will sharpen your analytical skills. You'll learn how to design experiments, control variables, and accurately measure changes in temperature. Plus, understanding these temperature changes can help in predicting the outcomes of chemical reactions, giving you a deeper understanding of reaction dynamics. So, let's get started and uncover the fascinating energy changes that chemistry has to offer. On to the practical. Let's start by gathering our materials. Sam, what do we need?
So, for this practical, we need sodium hydroxide solution, a beaker of hydrochloric acid solution, a polystyrene cup to act as an insulated reaction container, a thermometer or temperature probe, a burette for accurately measuring and varying the volume of HCl, measuring cylinders for initial measurements, and finally, a stirring rod.
Now we can get started. Let's place the polystyrene cup on a stable surface and ensure it is clean and dry. Now, take your sodium hydroxide, also known as NaOH, and a measuring cylinder. We can now measure 25 centimeters cubed of the sodium hydroxide solution using a measuring cylinder. Then pour this into the polystyrene cup. This will serve as our base in the neutralization reaction. As we're investigating a temperature change, we need to start by recording the initial temperature by placing the thermometer or temperature probe into the NaOH solution. Now read the initial temperature from it. Let's add this to a table where we will record our results. For this first experiment, we will be adding 5 centimeters cubed of hydrochloric acid, so add that to the first column. Then record the initial temperature before the acid is added, which is currently 19.5 degrees. Great, now for the next step. Next, we can add the hydrochloric acid. First, fill the burette with hydrochloric acid, also known as HCl. Then, carefully add 5 centimeters cubed of the acid from the burette to the sodium hydroxide solution in the polystyrene cup. Stir the mixture gently with the stirring rod to ensure thorough mixing. We need to observe the thermometer and record the highest temperature reached. The temperature from this reaction is 22 degrees. So let's add this to our table, writing the final temperature of 22 degrees in the correct column. That's our first set of data done. We now repeat the previous steps for the other volumes of HCl, 10 centimeters cubed, 15 centimeters cubed, 20 centimeters cubed, and 25 centimeters cubed. Use the burette to measure each volume accurately.
Remember, to ensure that we avoid contamination, we need to make sure to clean the polystyrene cup and thermometer between each trial.
Great work! We've completed our experiment. Here is the table with all of our results. Now we can either repeat the experiment or share the data with a friend so we have two sets of results that we can analyze. Let's see what Sam's results were.
Here are my results from when I conducted the same experiment earlier. There are a few differences here, so we will look at this more closely in our analysis.
Let's now move on to analyzing our results. For each experiment run, subtract the initial temperature from the final temperature to find the temperature change. These calculations are displayed in the two highlighted columns on the table. Then, for each volume of hydrochloric acid added, calculate the average temperature change from the two trials. The formula for calculating this is average temperature change equals temperature change from experiment 1 plus temperature change from experiment 2 divided by 2. Here are the results we get, so we have filled in the average column. To visualize this data, we can draw a graph. On the x-axis, plot the volume of HCl in centimeters cubed. On the y-axis, plot the average temperature change in degrees. Start by marking each data point corresponding to the volume of hydrochloric acid and the average temperature change. So first, plot 2.4, 5, then plot 4.0, then 5.5, then 7.05, and finally 8.5. Great work! That's all of our points plotted. Now draw a line of best fit to connect the data points. This will help to visualize the trend. From the graph, we can observe that as the volume of HCl increases, the average temperature change also increases. This is because the larger the volume of hydrochloric acid, the more hydrochloric acid reacts with sodium hydroxide, and the more product, which in this case is water, is formed. This formation of water releases energy, which leads to the temperature change.
Now we have a set of results, but how do we know that those results are accurate? It's important for us to go back and evaluate our procedure to highlight the choices we made to increase accuracy.
Good point, Sam. Let's evaluate what we did in our experiment to increase accuracy.
What was the benefit of using a polystyrene cup?
We used a polystyrene cup instead of a glass beaker because polystyrene is a better insulator. This helps to minimize heat loss to the surroundings, ensuring more accurate measurement of the temperature change caused by the reaction. If the reaction was endothermic, the polystyrene cup would prevent a gain in thermal energy from the surroundings.
Great point. Why did we use a burette?
The burette allows for precise measurement of the volume of HCl added to the NaOH solution, ensuring consistency and accuracy in the volumes used across different trials.
Exactly. We had very precise measurements in our experiment. What about stirring the solution?
Stirring the solution ensures thorough mixing of the reactants, leading to a uniform reaction and more accurate measurement of the temperature change.
Yes, exactly. And why did we compare the results from your experiment and my experiment?
Well, repeating each volume measurement at least twice and calculating the average temperature change increases the reliability of the results and helps to account for any anomalies or inconsistencies.
Great work! By using a polystyrene cup, a burette, stirring the mixture, and repeating trials, we ensured the accuracy and reliability of our experiment.
That's the end of our lesson today. Let's recap. Today, we explored how different variables affect temperature changes in various chemical reactions through a practical experiment. Specifically, we investigated how different volumes of hydrochloric acid affect the temperature change in a neutralisation reaction with sodium hydroxide. By varying the acid volume, recording temperature changes, and calculating averages, we observed that increasing the volume of acid increases the temperature change, indicating more energy released. This experiment not only reinforced our theoretical knowledge, but also demonstrated the real-world relevance of energy changes in chemical reactions.